Our next few examples are going to take a look at functions. Specifically, we're going to look at the graph of a function in order to answer certain questions. So for this one, function f, we can see that it's going to have kind of a couple different segments. So I'm going to start here at -5, -3, and have a straight line up to 1, 3. Then from 1, 3, I'm going to go down to 3, -3, and then we're going to go over here to 5, -2. So given this graph, let's answer a couple questions. The first thing we're going to find is the domain and range of our function. So the domain is going to tell us about what's going on with the x values. So how far left, how far right do our x values go. So looking at my graph, as far left as I go is over here at -5, -3, and as far right as my graph goes is over here is 5, -2. So for my domain, the furthest left point is -5 and the furthest right point is 5. And I do attain those values, so I'll have brackets on those endpoints. Now if I'm looking at range, range is going to look at the y values. So for looking at the y values, let's see how low our y values go. So they go as low as right here. So I've got these two different points that have a y coordinate of -3. And the y values go as high as that ordered pair at 1, 3. So my range goes as low as -3 and as high as 3. Alright, so let's get rid of those marks. For part B, it says list the intercepts, if any. So first let's take a look at x-intercepts. So here's my x-axis. So I have x-intercepts at the ordered pairs -2, 0, and 2, 0. And then now let's take a look for any y-intercepts. So looking over here on my y-axis, I have a y-intercept at 0, 2. So I have 3 intercepts. Alright, then for part C, it asks us to find f of 1. So this is giving me the x-coordinate, and it's then asking me what the corresponding y-coordinate is. So looking over here on my x-axis, here's x is 1. So I'm going to go until I hit my graph, and there's where I hit my graph, and so the corresponding y-coordinate is 3. So then I would answer that f of 1 is equal to 3. For part D, for what value or values of x does f of x is equal to -3? So remember, f of x is equivalent to y. So this is saying if y is equal to -3, what could the corresponding x values be? So I'm going to come over here on my y-axis to -3, and I'm going to extend that until I hit my graph. And there's going to be two locations that I have a x-coordinate with a corresponding y-coordinate of -3. The x values are -5 and +3. Finally, for part E, it says solve f of x is less than 0. So another way that we can look at what this is asking us is that where is the y values going to be negative? So for what x values is the y values negative? So the y values would be negative anywhere down here. Right? So let's take a look at then what x values then would generate these negative y values. So on this little branch right here, the x values go from -5 up to -2, but at -2 I'm going to have a parenthesis on it because that one is not going to be negative. That value is actually going to generate a 0. And 0 is neither positive nor negative. So then I'm going to have negative values on this stretch, and then I have negative values over here. So for over here, that starts at an x-coordinate of 2, and then that would go until an x-coordinate of 5, and at 5 I still do have a negative y value. So I can put a bracket on the 5, but on the 2 I'm going to have a parenthesis because that one does not have a specifically negative y coordinate. So I have these two regions, so I'm just going to put a union sign between them. Alright, so then on our next example we're going to continue looking at a function. This is going to be function g. So looking at this one, we kind of have a curve. It's going to go as far right as 4, 3, and then we kind of curve down to 2, -1, moving to the left. So then we're going to curve up to the left to -2, 1, and then we're going to curve down through the x-axis at -3, 0, and then we're going to go down to -4, -3, and then this arrow indicates we're going to keep going down right here. So the first thing on this one, let's find the domain and range. So for the domain, we're going to look at the x-coordinates. So because of this arrow right here, this branch will keep going down, and as it goes down, it's going to keep moving to the left. So I'm going to have a domain of negative infinity as far left as I can go, and then as far right as I can go is going to be right here up to 4 with the bracket on the 4. For the range, looking at how far down I can go, because this branch will just keep going down, my range will start at negative infinity. That's as far down as I can go. And then as far up as I can go, it would be up to this point 4, 3. So it'll end at a y-coordinate of 3. All right, for listing the intercepts, let's find maybe x-intercepts first. Okay, so there's my x-axis. So I'm going to cross the x-axis at negative 3, 0. The origin, 0, 0. And then over here at 3, 0. Looking at my y-axis, I don't get any new intercepts because I've already got the origin. Alright, let's take a look at the intervals in which g is increasing, decreasing, or constant. Alright, so first we'll look at increasing, then we're looking at decreasing, and then we'll look at constant. Alright, so first let's take a look at the increasing. So we're going to be looking at where I would have a little person that would be walking up the graph if he were to be on here. So if I put my little person right here, alright, so on this part right here, he would be going up a hill, and then from right here to here, he would also be going up. So I'm going to have two increasing intervals. This interval right here goes from negative infinity up to negative 2, and then union, and then this interval will start at 2 and then go up to 4. So all of the numbers have brackets on there, and then the negative infinity would have a parenthesis. All right, so then my decreasing interval is going to be right here. So right here on this kind of middle region, my person would be going downhill. So this is going to go from negative 2 to 2 with brackets on both of those, and then nowhere is my graph constant. Alright, so next we're going to be asked about local minimum and local maximum values. So for our local minimum, we're looking for a value such that if we build like a little tiny interval around that value, that one ordered pair would be the smallest y-coordinate in that literal interval. So looking at my graph, let's erase all these colors, I'm going to have a local minimum right here at 2, negative 1, because for a little interval around here, this is going to be the smallest y-coordinate that occurs in that interval. So I have a local min of negative 1 at x is equal to 2. So for a local maximum, we're looking for an ordered pair such that if I build a little interval around it, that y-coordinate is going to be the highest that ever occurs. And that is going to happen right here. So this will have a local max of 1 at x is equal to negative 2. And those are my only local min and local max values. Alright, so for part E, whether the function is even, odd, or neither. So remember, it's going to be even if it is symmetric with respect to the y-axis. It's going to be odd if it has origin symmetry, or it could just be neither, and it doesn't have either one of those. So looking at this, for y-axis symmetry, this graph doesn't have it, right? If I fold this over the y-axis, I'm not going to fall on top of the original graph. And for origin symmetry, if I take this graph and rotate it 180 degrees, I'm not going to fall on the original graph. So this one would have neither even, this graph is neither even nor odd. Alright, and then connecting to that, determine whether or not the graph is symmetric with respect to the x-axis, y-axis, or origin. So we already talked about the y-axis and origin are out. So let's just talk about x-axis real quick. Looking at this, if I take this graph and I flip it over the x-axis, I don't fall on top of the original graph. So this one will have no symmetry. Okay, so finally, our last example that's going to involve looking at some functions. So I'm given f of x is equal to 2 minus x and g of x is equal to 3x plus 1. So we're going to do some function operations. So first let's find f plus g where we add these guys. So that's going to be equal to 2 minus x plus 3x plus 1. Now the parentheses right now are optional around those two expressions. It never hurts to put them in there, but you can see I don't actually need them. So I'm just going to go ahead and drop them and then just combine my like terms. So then I'm going to get 2x plus 3, and then the domain for this is going to be negative infinity to infinity. For f minus g, so I'll have f of x is 2 minus x minus g of x is 3x plus 1. And in this case, the parentheses do matter because I will need to distribute through the second set of parentheses. And then I can go ahead and combine my like terms and get negative 4x plus 1. And then the domain for this is, again, negative infinity to infinity. All right, next find f times g. So I'll have 2 minus x times 3x plus 1. We'll go ahead and distribute that out. So we're going to get 6x plus 2 minus 3x squared minus x. And then normally we put these powers in decreasing order. So I'll have negative 3x squared plus 5x plus 2. So since I ended up with another polynomial, I don't have any domain restrictions, so my domain is negative infinity to infinity. And then finally for f divided by g, so I'll have 2 minus x over 3x plus 1, and there's really not that much I'm going to be able to do to clean this up. But this one, I am going to have a domain restriction. The 3x plus 1 is not allowed to equal to 0, which means x is not allowed to equal negative 1/3. All right, so my domain then is going to have to exclude that value. So if I want to write that in interval notation, this would be from negative infinity up to negative 1/3, union negative 1/3 to positive infinity, or in set builder notation, it would be the set of all x's such that x is not equal to negative 1/3. All right, so there's my function, and there is my domain.